building, which I'm really happy to be coming back to a couple days a week. And we're very excited to cap off this amazing week with a tour both in the CCNY Planetarium, and then our director, James Hedberg, will ask us to strap on our jetpacks and blast off over the neighborhood and then off into the solar system and beyond. So he's prepared a really nice tour for us, and I'm going to turn it over straight to him. So James, you may take it away.
Thank you, Dean Perkins. How are you all doing?
Good.
Good. All right, great. I'm never sure if I'm going to be able to hear everyone, but anyway, I'll just talk nonstop for the next hour. How about that? Welcome to the planetarium. It's been a year since I've been able to say that to anyone, even though I'm just staring at the walls right now, but you're out there and welcome. This is, I guess, 14 floors below where Susan's sitting right now. We're in the basement of the Marshak building, and which is, it's all right place for a planetarium. What you see behind me is the original structure, the original instrument that was installed getting close to 50 years ago now. I think around 1973 when the building was built. And if you look around, you will see a room that is virtually untouched by time since then. It has remained almost exactly as it was. We painted the walls and have installed some new HVAC equipment recently, but otherwise than that, it's a classic vintage planetarium. When I first got to City College in 2013, I saw little signs on the walls that said there was a planetarium in the basement, but nobody really talked about it. I asked some people where it was, they didn't know. And so I ventured around and got lost in the basement and eventually found it. And well, then I had to go back upstairs and get the keys, but got the keys and came down and discovered this beautiful room. And since then, I've kind of made it one of my missions at school to bring it back to life. It has sat somewhat unused for a little too long, but we are in the process of bringing it back. We don't use this instrument anymore. So one of the big steps we made was to install a digital system, which you can't see, but which I can see right here. It's behind me. And what that enables us to do is project all sorts of marvelous stuff up on the ceiling. And that's the system I'm going to show you the tour with today. Not that I don't like this. This is called the Spitz 512. This is an amazing instrument. And if you really want to see beautiful stars, this does it fantastically. But it doesn't transfer so well online. So we're going to switch over to the digital system. Allow me to walk back to the cockpit, and I'll see you there shortly. All right. Every trip to the City College Planetarium, well, maybe not every, but most of them involve a trip, stop on the subway. So that's where we're going to begin our tour. Just a quick little look around at the 135th Street subway station. I was just there the other day on my way up to campus, and it's largely remained the same. What you're seeing now is just the beginning of our full-on universe simulator, which is what we operate down here in the basement. This is a piece of software developed by some colleagues and friends in New York at the Museum of Natural History and some other institutions as well. So as we leave the subway, we see some buildings coming into view, and eventually we'll get to the surface of the Earth. And that's where we are. And let's look around. So this should be somewhat familiar for anyone who's ever come up to campus. There's St. Nicholas Park. There's the Marshak Science Building. Let's get a little higher up so we can see the whole campus. And you just, you'll have to forgive the occasional pause. Normally, we might have one person talking and one person flying, but due to the social distancing protocols, we've got one person doing both. So it does take some serious concentration. Anyway, there's our campus. All right. There's Shepherd Hall, there's Marshak, the NAC building. There was a little discussion earlier in the waiting room about where the student center might have been. I don't know, but I'm sure someone in the audience does. I'm guessing it might have been the architecture building, which used to be known as the Y building. And that's this one right here. That's an old building. Now it's the architecture school, but these buildings over here, the South Campus, those obviously weren't there 10 years ago or 100 years ago, but now we can see them. And let's just pan up a little bit and we can see where we are in the whole island of Manhattan. And we'll go up a little bit so we can get a better view. Okay, now a lot of you I know probably, if you're on the younger side of things, you've grown up with Google Earth at your fingertips and maps and no shortage of amazing pieces of technology to visualize the world. So you might be a little picky and saying, hey, why don't your buildings have all the windows and doors and signs? And those are just little white blocks. And yes, you're right, those are not the best buildings we have, but in this case, we have to pick and choose. So what we're looking at is just one small part of a much larger simulation of really the entire universe. And so when it comes to all the windows on the buildings, we're going to have to leave a few things off. Otherwise, we would need a much bigger computer. Okay, so we're going to go downtown. And I'm just going to show you some of the stuff that we like to do with the planetarium and its visualization capabilities. Let's see. So I'm going to steer over here. I think this is where I want to be. And pause. And now you'll notice, well, you might not notice, but you'll see that I've picked a very special day to start this tour. This was the date on my universe simulator is set to July 12th, 2020, which if I start to fast forward time a little bit, so I'm going to move my clocks ahead quickly, and what I want to get to is just before sunset. So let's go over here to this side, and I should mention that all of the data you're seeing here of all the buildings is provided by New York City Department of Information Technology. They've mapped every building in the area, I'm guessing for tax purposes, but very handsomely they provided this data set for anyone to use. And so we've imported it into our universe simulator, which is called Open Space, by the way. If anyone wants to play around on their own computers, it's open source and free. And so here we are looking across Manhattan, and maybe some of you were around this day, July 12th. And if you speed up time a little bit, so we're going to just go forward in time, and then we're going to watch the sunset. And we'll be right down here by 34th Street or so. And let's zoom in to get a little better view. And we can pause right about there and speed up the time. And on this day, this very special day, what we discover is that the sun, as it sets, is aligned perfectly with the Manhattan street grid. So this is the phenomenon known as Manhattanhenge. If you're out on the street that day, you'll see a whole bunch of people trying to photograph this event right here. All right, where the setting sun lines up perfectly. It happens twice a year, and once in the evening, and then in the morning. It's also can occur, but it's quite an event. And this highlights sort of what we're working with in terms of visualization down here is a full-on date, time, geography, simulation of the cosmos. Okay, so here we can see the sun. I can turn on all the other planets behind them. That's what you see in these trails going through the sky. And it's using NASA data to accurately predict and plot where every single thing is going to be. Okay. I should say, if there are any, I guess probably better wait till some questions at the very end, but if there's an emergency question that you can't get resolved, I'm happy to try and take it now too. Okay. So we can do all sorts of great stuff with this. You're all familiar with Manhattan though, so I don't want to spend too much time here. All right, so let's go. As Dean Perkins said, we're going to strap on our jetpacks and take a flight up. All right. Other aspects of this that we enjoy are the sunsets in this simulator look fantastic. And I just need to go back in time a little bit so we can get to daylight hours there. And now you can see the whole surroundings of the metropolitan area. And so one thing we usually do when we have classes come in is we ask everyone where they're from. All right. And there are from all over the place, let me tell you. So whenever I have a group of students come in, it becomes a geography quiz for me because they want to go to Korea and Ecuador and DR and all sorts of countries all over the world, which I should say can be hard to find if you don't have any borders on your maps. So it's always a nice challenge. We're going to just head up north a little bit up here because I want to highlight another thing that we like to do in the planetarium. And that is trying to visualize not just astronomical data, but other disciplines as well. So you should see these little twinklings coming into view now. These little twinkling X's. All right, because there, let's get a little closer. Great. So you can see these little X's floating around down by the water and up in the sky. These are GPS positions for an eagle as it was flying around for a few weeks. There's a lot of people that share their bio data and make it publicly available. So we decided to download a little bit of it and try and pretend we're an eagle. So records the latitude and longitude and altitude every 10 minutes or every hour, whatever their protocols are, and then spits it out and we can plot it. And so we can recreate the voyage of a little bald eagle as it flew around the Catskills. And so this is one thing I'm really excited to do more of in the planetarium as we develop ourselves a little bit more, is to bring in other scientists and their data and explore not just the cosmos, but maybe the microcosmos and our universe as a whole, every length scale. Is there a way to, sorry, I'm used to teaching in Zoom now, and I can't help but look at the chat. So if it's to me, yes, is there a way to move from GPS to GPS point as the eagle flew it? Yeah, absolutely. We could, that would involve just a little bit of not terribly complicated coding, and we could plot a course that followed exactly that eagle that day. It might get kind of tedious when he stops for lunch for an hour or takes a nap, but yeah, that's totally within possibility. Okay, so now we're gonna go a little higher up and start to see the entirety of our globe. All right, so now we're looking north, and we've just left really the atmosphere, and we start to see the Great Lakes. There's the eastern seaboard. And if we go high enough up, we'll see all of North America. And I'll pause right there. And we can just admire this view. So what we're looking at is, it's a combination of historical satellite imagery of terrain, that's what's on the bottom, but then also the cloud layer that you're seeing is actual weather from recent times. So I believe my date was still set for July 12th, 2020, but I could jump to yesterday, April 22nd, and now we load in the clouds that were over North America as of yesterday. All right, and if we wanted to get more fancy, I'm sure we could figure out ways of bringing in up to the minute weather, but we're going to leave that more to the professionals. Weather forecasting is not going to be my strong suit, but all right, so there's the Earth. I forgot to turn on one thing that we all would expect to see in space, and that is some stars. Okay, let's turn off those planets for now, and we're going to just slowly take off from Earth. We see the Milky Way coming into view. Or actually, what you see is the dust from the Milky Way. Those dark smudges are the parts that are blocking the stars behind it. And we'll pause right about there. And now I want to take you just on a quick trip around the solar system. So we'll start with our nearest neighbor, Luna, and fly into there. You see it coming into view. And now, just like we have satellites going around Earth taking pictures all the time, there are satellites going around the moon all the time, taking pictures and bringing back beautiful, beautiful data showing the surface of the moon. All right, and so we can kind of get a little closer and begin to see the topography of this lunar surface. And now we're struggling. It's coming into view. It takes a lot of internet speed to get these craters happy, but they should start getting a little bit better resolution in a moment. But one thing I like to do is when we're in the planetarium and we have a school trip here, we go find a nice crater and invite everyone to open their picnic baskets and have lunch while they're sitting in a crater. There, that's better. We haven't, oh yeah, sorry, we haven't gotten in as far out as the AU yet, but we'll go that far soon. I got the next destinations are coming. So there's the moon and the crater. And this isn't, I'm not even showing you the highest resolution data we can plot on here. This is sort of the lowest resolution, in fact. But we can go in and, walk around the area where the Apollo modules landed and see things a little bit bigger than boulders if we fly in close enough. They just, it's not part of this trip, but when you all come back for a real in-person show, I'll be happy to do it then. Okay. And I should mention, I guess I can mention now, what you're seeing is actually our photographs merged with height maps, right? So we have data that shows how high everything is and what it looks like from a camera, but we can also plot all sorts of other great bits of data on the moon. You can put the chemical composition on there and see other data mapped to the sphere. Let's zoom out. And you can also do what we normally can't do from Earth, and that is see the backside of the moon over here, right? So normally one side is always facing away from us, but if we scroll through time a little bit, we can begin to expose that side that's not visible. So this would be the, I think if I can see there, if you see Earth up in the top of the screen, now we're looking from behind the moon when it would be affected, almost a new moon on Earth, and you wouldn't see anything, but because the other side, the back side is illuminated. All right, so these are the great things we can do down here is see views that are just physically impossible from the terrestrial globe. All right. And I'm a little more adventurous with the flying since we're not all in the dome and probably no one's going to get motion sickness, but it does happen. I think the first time I sat in here and started turning the heavens, I felt a little queasy, but then you get used to it. Okay. So let's turn the solar system trails back on so we can get a sense of scale. And there's the moon around orbit of Earth. And we're just going to keep zooming out a little bit. And this is one of the great things that we can do in the planetarium pretty easily is talk about senses of scale, which we find a lot of people just don't have a good feeling for how big stuff is in space. It's enormous. And so we can put people in different vantage points that make it a little more obvious how large this thing is that we have as our solar system. All right, so next planet on the list, we're not going to be able to go to all of them, but I do want to hit up one more because it's been in the news a lot recently. Let's go to our next furthest out neighbor, and that's Mars. Okay, so there you see the blue trail for Earth going out of view, and Mars is coming into view right now. That has the red trail. I'm going to turn off the trail so it doesn't distract us. We should see the globe of Mars coming into view right about, just blinking in right there. Great. Okay. Oh, wait a minute. This isn't Mars. What's all that blue? Looks like we took a wrong turn and ended up about 4 billion years ago when Mars had oceans. So this is you're looking at a semi-scientific, semi-artistic visualization of the ancient oceans on Mars, right? So it's pretty clear that there was liquid water at one point. The question now is, where did it all go? So some scientists are trying to figure that out. Did it all evaporate due to the lack of a magnetic field on Mars, or did it get buried under the surface? I don't know, but we got our best robots on it. And I'm going to turn off that water there. So this is a real view of what Mars looks like today. So these are you can see this enormous canyon system coming into view over here. This is known as Mariner Valley, larger than the whole United States, and many miles deep. And normally I like to come sneak down here into the planetarium and just fly around these canyons in the valleys. It's a nice little way to escape. Don't tell Dean Perkins. But there we go. And so this is a view. I can increase the resolution of these images a little bit, maybe. And we can get a feeling for what it would be like to fly around on Mars, which they just did yesterday. The little helicopter took off. And I don't know what it's doing today, but it seems like views like this won't be out of the question in a couple more years. So this is all, of course, simulated. We're just taking the data from the surface topography and the images of Mars and turning it into a globe that we can navigate around. But who knows? We might be able to capture some live feeds like this in a little while. Okay, so that's Mars. I did want to, let's see if we can get there in just a few minutes. I don't want to spend all day on Mars. I would like to spend all day on Mars, but there's other stuff. So I'm going to jump over to this region. It all went black because it's nighttime over here. Okay. And so I got to move ahead a little bit to where it's daytime. And I'm going to turn on some more interesting data sets. And we're going to zoom into the surface. And as you get closer, you should see this outline of a crater. That is, of course, Jezero crater, where the Perseverance rover just landed a few months ago, or a week, yeah, not too long ago, and is now starting to explore. And there's also this little patch of a rectangle you can see there. This is what we call a high-rise data set. And this is exceedingly high resolution data. So you can see features that are rock sizes with this data set. And we have patches all over Mars with it. And this gives you a great idea of what the surface of Mars would be like. So you can see sand dunes there, and little hillocks and all sorts of features. And it really exposes the geology and surface science of the planet a little bit more than other views do. So now you're looking at stuff where the length scale of these features is in the order of a few meters. Okay, so if I had if we could, I guess we could have put the little model of the rover in here. And if we did, it would be just a little buggy on the surface. But this is sort of the view it would have traveling around Mars. I just saw the moon comment. All of the data, there shouldn't be many optical illusions with this. All of the data is pretty as accurate as it needs to be. And there are, of course, some artifacts now and then, like you can see off to the right, but we're going to ignore those. That's where the two surfaces, the high resolution and the low resolution terrains, just don't quite line up. All right, so we've been traveling for a little bit. I'm going to just take you to a few more destinations and then we'll head home. So let's take off from Mars, like maybe some lucky souls will in a couple more years. And now I want to go far. So let's see, where is our solar system? Those are the two moons of Mars going around. They're little teeny moons, not too fun to explore. And we'll do one more planet from the solar system. And that's generally everyone's fave, and that's Saturn. So we'll get there real quick. Normally these trips even if you were a light photon would take many hours, but we'll get there in a few seconds. So Saturn, of course, has many moons, but as well, it has these gorgeous rings that are simulated here as well. And so just need to turn that off. Let's get a little closer. Those are a bunch of the moons of Saturn. I don't think it's all of them, but a lot of the moons. And now we can enjoy the vistas from the rings of Saturn. Turn all that off. And just relax, enjoy the view. And so a lot of this imagery comes from the Cassini missions that spent a number of years in orbit around Saturn. Unfortunately, we can't fly into Saturn, even though it is just a gas planet. But maybe one day we'll improve the simulator and so that we could fly into the gases of Saturn. That would be pretty fun. And let's zoom out again. And now I want to show you just the whole grand scheme of things, right? So let's turn on our solar system again. Okay. And now one thing that a lot of people know, associate with space are the constellations, right? And I spent a lot of this summer learning about the constellations because even though I am a planetarium director, I have not learned a lot about the constellations till now. And so here are the 88 constellations. And if you grow up in New York, you're not going to get to know many of these, right? The stars are too dim. You might be lucky to see Orion over there on the right and the Big Dipper, but a lot of the more subtle ones are going to just be washed out due to light pollution and regular pollution. But down here in the planetarium, we can turn them on and make the stars as bright as we want, right? And it's giving me a chance to explore the southern hemisphere stars, for example, because that I physically couldn't even see being in the northern hemisphere. Okay. And now I'm going to turn on the constellation lines and turn off the drawings. And now you see the familiar constellation lines. And I want to show you a view that always just it changes my perspective with the galaxy and the universe every time I see it. And that's when we start going far out of the solar system. So now we just see the little dot of our sun. And so now we're getting so far away that we're passing the other stars. Okay, and so this is a sort of understanding of the galaxy and the universe that the ancient astronomers would have been impossible for them to comprehend, because they didn't think that it was a three-dimensional structure out there, but it is, right? We all know now that the stars are not just plastered on a glass sphere, but are located at all sorts of different X, Y, and Z coordinates. And so their constellations, even though they were drawn on a ball shape, were really three-dimensional objects. And so they don't make sense when you go far enough out. It becomes a cluster of lines and incomprehensibility. All of those lines there those are the stars that make up the constellations. And as we go farther out, we'll see the whole Milky Way coming into view. And if our rotations are just good, we'll get a pretty spectacular view of the Milky Way and sort of where we are in it, and just how little of it our night sky actually encompasses. So all of those constellation stars are in that little quadrant, or the little section over on the top right of the screen now, right? I don't think you can see my mouse, but those lines are connecting the constellation stars. And so that's all that we can really see with our naked eye, is that little bit. Or that's what we've made the constellations out of. And of course, we can go much further out and see other data sets as we go further out. These are some local galaxies nearby our Milky Way. And if we keep going even further out, we'll get to large-scale structures of the universe, which would look something like this. So these are the results of the Sloan Digital Sky Survey, which plotted galaxies as far as we can make out. And one of the big topics of cosmology that people look at is trying to figure out why there's more galaxies in some places than others. Why do you see those little filament-like structures in there? The hourglass shape you're seeing, I should just mention, is only because our Milky Way galaxy is obscuring all of the galaxies on the right and the left. So we can only look out of our Milky Way plane. We can't look through it. So that leads to this hourglass shape. Presumably there should be galaxies to the right and the left. We just can't see them. Okay. And that's about as far out as I care to travel. I like to stay kind of close to home. So let's go back, and we're gonna return. I don't want to leave you stranded out in deep space. So we're going to go back and slowly return to Earth. And I'll play a little calming music on our way back. So in the planetarium, we often take advantage of all the media, different formats we can have, right? So we have music and visuals. We even have some tactile models up front there of the lunar surface. We have a crater that was 3D printed. And so we have students come in and feel what the surface would look like, and so forth. And so it's a real all-encompassing environment in here. I guess we could serve astronaut ice cream too, but generally we don't have a snack. We don't have a vending station yet, but maybe one day having a snack bar would be fun. Okay. So we're getting close to home. There's our sun. And we see the solar system coming into view. And we're approaching Earth. And now, when we get to Earth, we see that it's a little bit different than when we left it. And so I just wanted to share this as a little personal shout out to my family at home. This, who I believe is watching, I think they're there. This is a hand-drawn globe of the Earth by none other than my 5-year-old daughter, who, if she's there, hi Viola. And she made this map of the Earth. And so one thing, this is the last little bit I want to mention about what we like to do in the planetarium, but we also love to mix the arts and the sciences. There's no reason this room just has to be for astrophysics. It can, any discipline at City College has something to do down here, I believe. And we've had a few shows involving art and science overlaps, but we'd love to do more. And so as we move on, I hope, and as we begin to reopen, I think that's something I'm definitely interested in, and would love to hear if anyone out there is also has ideas for that, then let me know. And with that, I think I'll turn off the motors and hand it back over to Dean Perkins.
Thank you so much, James. That was so cool. I think it was especially poignant because we haven't gone very far in the last year. We've been pretty stuck in place. And so that was incredibly freeing to not just escape New York City, but to even escape the galaxy. So I probably should have been asking you to do this much more regularly for us during this past year. Are there other questions that anybody has about the planetarium, about what we just saw in space? Is there another place you'd like to go? I'm seeing lots of great comments from folks. Elise.
Hi, thank you so much, James. So I think I've met you before, but my name is Elise Krall, and I'm a professor in the philosophy department, but I teach history and philosophy of physics, of science. And I often begin my general philosophy of science course with an overview of the history of astronomy, just to show underdetermination, right? That we can have the same astronomical data, but nevertheless many different models. And I'm wondering, have you got some cool shows that show like the Copernican model versus the Ptolemaic model versus that sort of thing? And what other fun historical programs have you got?
All of them, yeah. That's my favorite stuff. I enjoy that more than modern physics sometimes myself. So absolutely, I've started a Ptolemaic system into here, and I just a few weeks ago I did a show with the California Academy of Sciences where I took Ptolemy's original star data and we plotted it next to the current stars, and saw some of the systematic errors and other relations between those two data sets. So for anyone who's maybe not familiar, that those are 2,000-year-old tables of star positions that we can put on our dome down here and pretend that you are Ptolemy living in Egypt looking up at the night sky. So absolutely, yeah. When the doors open,
great,
we'll do something fun. Yeah,
love it. I'll get in touch with you. Thank you.
I just wanted to share, I just put the link to the planetarium's website in the chat, and James regularly does really cool blog posts, and a lot of them do include some of the history that he's interested in. So follow along there as well. And he's fantastic with our social media. So follow on Twitter and you'll get links whenever there are new posts. I'll put the Twitter feed in there as well. I think there's a couple other questions, James. You can see them, right? You don't need me.
Yeah, let me see. Can we simulate a meteor hitting the Earth? Right now, no. So this software, again, it's called Open Space, and you can go get it yourself. It's just a large download, and it requires a pretty hefty computer to run, but you can go get it. But it's not so much of a physics simulation device. You don't push go and let gravity bring things together and see what happens. It's more of a data visualization thing. So if, for example, you had a data set of maybe a meteor hitting the Earth and stuff, then that's something we could work on visualizing, but we can't just, take a rock and throw it at the Earth and see what happens. But someone else can maybe. And how can we arrange field trips for New York high school students? Just send me a note. We had a few, we started ramping them up right in January last spring. So then we had one scheduled for March 16th, I believe it was, and March 13th, we had to close everything down. So when that status has switched, I won't be the first to know, but I'll be the first to, I'll definitely share it on our pages and so forth. So that's going to be the best way. But anyway, send me an email and we can coordinate. And it's fun. They love it. I love it. We have some physics students that help out as well. Sometimes they come in and assist with the narration during the show. I'm the only licensed driver of the software at City College, but hopefully we can also train some other people to use it and get it going. There are, I guess, so that's sort of like the last question. We don't have a lot of dynamic processes in this software. It's not necessarily built for that, but if someone does generate those data sets, then maybe it's something we can do in here. But at the moment, I don't think we have that stuff. And astronaut. Yeah, so I didn't show any of these other things. So we have almost all of the major NASA missions loaded in here as trajectories and model spacecraft. And so the ISS, I think I turned it off for this installation because I wanted to conserve my memory and stuff, but there's the International Space Station is in here, the Mars rovers are there, all the Apollo missions, because we have that data. We can plot all that stuff and follow the spacecraft as it moves through the sky, on its way to the moon. And that's a ton of fun. And that does bring up the next question of sort of gaming and yeah, like you can, I have a little Xbox controller that sometimes I plug into this. It's not as smooth as you think it would be. I actually started making one at home with joysticks and Arduino, so I could make my own little cockpit, but haven't finished that yet. Need some more hardware. But yeah, you could imagine all sorts of great stuff where guests in the room would take the reins and, try and navigate their way around and find those countries that I have a hard time finding.
There's another question from Alan Weinstein.
Where is that? Oh, Air and Space Museum. I have not been in touch with anyone there. Most of my friends involving with this software are at the Museum of Natural History and a couple other, there's a big center in Sweden that's also part of the open space project. And so that's most of my contacts are there. I haven't done anything with the Air and Space Museum, but I put all my stuff out there. So if they want to find it, they can, or if they want to enjoy my media, they're more than welcome to. But they have much more powerful computers than I do, I think. So I'm not sure I can compete with the big science visualization studios, but I've got the passion.
You sure do.
And computers are getting cheaper and cheaper.
Yeah. So I put in the chat too, we have big dreams, big ideas for continuing to improve the planetarium. I think I put in there, I was actually at the American Museum of Natural History before I came to City College. So I'm well aware of the draw of planetariums and how much fun it is to have other events in those spaces. So when I came, I met with James right away and learned about some of the previous events that he had hosted. And I should add, we do need to make one incredibly key renovation because the planetarium is in the basement of Marshak. It's not completely ADA compliant. So we have ways to get anyone who has any mobility impairments into the planetarium. But what we'd love to do is get that improved so that we can open it up much more broadly, because of course we want to be as inclusive as possible and let everyone come and enjoy whatever it is we're projecting on the dome or listening to. So we will continue to work hard on that.
Yeah. We've done a few facilities upgrades so far, but that's the big one that I can't wait to see.
Yeah. Are there any other questions? Well, thank you so much, James. This was just a fantastic way to wrap up the week in science. I hope we'll convince you to do a few more tours for us in the near future. What we've learned in the pandemic is the silver lining of Zoom and getting together remotely, so we can join together people from all over the world and, like I said, escape these bounds, which is so important right now. So
yep.
And thanks to all of you for joining us. We really appreciate this, and hope you have a great weekend wherever you go in space. All right, bye all.
Okay, see you. Thank you.